or POH? Because I don't have that number. How do we type it in a calculator? So you're going to have 11.16. Notice that's a 2 decimal place, so your answer should be in 2 suffix, equal to negative log of OH minus. How do I do this? Again, I'm going to send that negative to this side. So I'm going to say negative 11.16 is equal to log of OH minus. Remember how we said what we can undo the logs is you do the 10 to the power. So you're going to say base 10 to the power, 10 to the power. So then that will drop out and you're just going to get OH. So what you're going to type in your calculator is this. You're going to do concentration of OH minus is equal to 10 to the power negative 11.16. That's what you're going to get. Okay, you have to type it in. Again, I won't be able to do it without the calculator. What I can do is I can estimate them. Okay, now here's the thing. You might say, Michelle, how do we estimate it? We can, sort of. You have 10 to the negative 11, it's 10 to the negative 11. And then you have this a little bit extra that is multiplying it, right? Or the adding part, the power thing. If the power is adding, that means you're multiplying. I don't know if you guys know that about math, okay? Basically, simply put, if you were thinking about this, you will see that that's going to give you some decimal answer. So your answer would be actually smaller than 10 to the negative 11, basically, when you write it in the thing, okay? So you're going to say that 10 to the negative 11.16, you will see, right, what I told you, right? It's going to be smaller than 10 to the negative 11. You're going to get 10 to the negative 12. That part gives you some number, right? So in this case, you get 6.9, 10 to the negative 12. Okay, notice that 2 decimal place, so 2 suffix, so I'm going to only say 6.9. Okay, so 6.9 times 10 to the negative 12 molarity. Okay, on the test. Earlier, remember how I kind of find acid base without solving for actually the other guy? You can. The way that I tell is this. I look at this number. If this is more than 10 to the negative 7, then it's higher concentration. If it's less than 10 to the negative 7, it's a lower concentration. Okay, has less than the other guy. So you see how 10 to the negative 12, that is smaller. Negative 12 is smaller than negative 7, right? So therefore, I will have more H plus than the OH minus. This is acidic. Okay, and of course, this is basic. Okay, also, you will notice that when you finish, you will also know from the pH or POH. pH, if it's basic, should be less than 7, right? And then POH should be more than 7 for the acid. If it's basics, the other way around. So in the acid, right, this is the acid. And then this is a basic. Kind of makes sense? How I did it without actually solving for every single piece. Okay, I'm not solving for the rest. I want you to solve for the rest. Yes? Okay. If you guys are not done yet, I will give you guys a few. Yeah, we got those? Yeah, more or less. Okay, so when you guys are done, I want you guys to go ahead and take a look at this one. I know you can see the color, but you can see the number label there. So you're going to use those labels to try to tell what kind of pH it is. Here is what I do. Take a look. You want to talk about methyl orange. So I'm going to look at methyl orange, which is here, right? Okay, so I want methyl orange to be orange, and I want methyl red to be red. So I'm going to look at methyl red. It's red. Okay. Since methyl red is red, right, that means it's going to be less than pH of 4. Agree? Yeah? Because after 4 is yellow, so it's going to be less than 4. Bromothymol blue is yellow, so I'm going to looking for bromothymol yellow. Yeah, so less than 4 still work. Phenethylene is colorless, and aerosols is yellow, so that's yellow. Yeah, so all this kind of point to pH being less than 4. But let's see if we can narrow down. Okay, orange. Metal orange is orange. So what does that mean? That means it's not red, it's not yellow, it's somewhere in between. So we're looking for pH between, I would say 3 and 4, somewhere there, right? So we're gonna say between 3 to 4 pH. I say, make sense? Yeah, kind of. Okay, I want you to go through that. You can have these for multiple choice tests. So I want you guys to figure out if you guys can tell what's color. Okay, can I say again? Yeah, sure. Take a look at this. Metal orange is orange, right? Take a look at metal orange. When is gonna to be orange? It's between here, right? I mean, it's not 2. We know maybe like somewhere here, the range, right? Like maybe 4, close to it. Like I said, but since I don't really see 3, I'm saying like it's somewhere between 3, 4, maybe even close to 4, right? I would say. Do you kind of see that? Which you're gonna use the rest to like determine is that thing correct. So metal red is red. So if you look at metal red, yeah, 3 to 4 is gonna be red. Okay, and then bromothiamine blue is yellow. Yeah, it will be yellow at this range. And then phenolphthalein is colorless. By the way, the magic experiment that we did, like those little bottle, that was phenolphthalein. That was in there. That's why it was colorless. You can see them. And then when you put a basis solution into it, it's all of a sudden turn pink. And then once I ask you guys to pour in acid, it's go back colorless again. Magic of pH. That's what it is. Okay, Aerosol is yellow and red. Okay, that's what it is. I don't have time yet. If I have a little bit more experiment, I will show you some of the like crazy like magical experiment with these, which is kind of like cool because you were like, oh, I didn't expect it. Actually, you didn't know that I put a little bit of these indicator in the bottom of the container. So when the pH change, it could change the color. That's what the magic is about. See? All right. Solution 2. Take a look. Methyl orange is yellow. So let's look at methyl orange. Which region is going to be yellow? Well, yeah, 4, 5, maybe even after, right? Because what they were saying is after that pH will be yellow. Make sense? So that's what they were saying. So it doesn't stop there. It's just saying after that it's going to yellow. After this is all red. Okay? So it's yellow. Does it kind of make sense? So it's like after 4. And then metal red is orange. So that's 4, 5-ish, maybe. Because after 6 is yellow. Okay, so I'm going to say maybe it's 5. Fair enough? Yeah, so I'm going to say that it's 5. And then you can double check with everything else. Bromothiamine blue is yellow, which makes sense. 5-ish. Phenolphthalein is colorless. Yeah, and then this is going to be yellow. Yeah. Make sense? So that's what you're going to do. You're going to look at this with the pictures to see if you can tell, is it colorless, pH? What is this? What pH is this? So the next 2, what do you guys get for 3 and 4? Right, it's about 8, yeah, I would say. And then 4 is about 10, 11, yeah, about 11-ish, right? So yeah, you can say, okay. Yeah. Yeah, the last one go back, yeah, right here, like the pink and orange. Okay. All right, guys, we're back. Number 5. Okay, pH of the sample of a human blood is measured about 7.41. Calculate the pOH, H plus, and OH minus for this sample. So you should be able to figure out what they give you here is pH. They said pH is equal to 7.41. How do we calculate pOH? Right, 14 minus pH. I'll just write the formula, and then you can figure it out. All right, how do you calculate H plus? Right, 10 to the power negative pH, or negative 7.41 for this case. How do you calculate the concentration of OH minus? This one could be calculated 2 different ways. Okay, yeah, 10 to the negative of pOH. Okay, how about I use the H plus instead to find it? Yeah. 1.0 times 10 to the negative 14 divided by H. Right? So you can also do that. Make sense? Because H plus time OH minus is this. So you should be able to figure it out. 16.5, so that's a new package. All right, so let's take a look. We're gonna try to explain this here. Why double arrows in the opposite direction are not used in a reaction shown below? Yeah, because HNO3 is a strong acid. Okay, what about strong acid that we don't need the double arrow? There you go. That's the word we're looking for. Okay, so it's not enough to just say this. You want to explain what a strong acid is. That means it's dissociate completely, right? Into ions, right? Completely. Actually, I'll probably say completely here. It's completely dissociate into ions. But yeah, okay. All right. Write the reaction that show the chloric acid behave in the water. Okay, chloric acid. So you need to look in your papers, or you need to remember what chloric come from. Okay, chloric is ClO3. ClO, right? Yeah. So what is the chloric acid? H. I'm gonna add H to it. I believe it was ClO minus 1, and then so you're gonna add H to it. Chloric. No, ClO3. I was right. ClO3 minus 1, so you're gonna add H to it. Chloric part is a little bit confusing. You kind of have to remember that it was 3, and then 2 is a chloride, and then you also has 4, which is perchloride, and then hypochlorite is just ClO. I know it's hard to see, but you have this paper with you already, right? So again, I would suggest you to remember them. There are rare chances that you will see some of the iron in there that you don't use often, so you do need to know them, okay? So how is it going to behave in water?
It's going to dissociate.
It's going to dissociate into H plus and then ClO3 minus. Don't forget to write plus and minus. If you guys do not write them, you will lose credit on these, okay? So let's talk about this guy, number 2. Is HClO3 is one of them that you have to remember.
Yeah.
Do you remember your 7? It is. Okay. 1 arrow only. Make sense? Okay. All right. Concentration of H plus in a strong acid is, they are the same because they dissociate completely, right? So the concentration do not change. Now, this is not the case for the weak acid. Weak acid concentration will be different. Okay, let's go ahead and write the pH equation. How do you find the pH?
14 minus
Negative logs of H plus or H2O plus, doesn't matter. Okay, so that means, remember, HCl is strong acid, right? So therefore, these are also equal to concentration of H plus. Agree? Okay. Okay, so keynote is strong acid, concentration of HA. A stands for just acid, any acid. Right, strong acid HA, concentration of that is gonna equal to concentration of H plus. Okay, you want to remember this. Okay, notice 2 suffix equal 2 decimal places for the pH. Okay, so you're gonna quickly try to figure out what each one are. You're gonna say negative logs, not ln, 0.5. Oh wait, no, backwards. How do you find pH? 10 to the negative power. See? Backward. I'm already doing them. So remember that one. pH is 10 to the negative power of H plus. Okay? So this one will give you 0.32. 0.32. Yeah.
Wait, no. We were doing it right. The equation, you used the long one.
Yeah.
Hmm?
You plug it into long.
Oh, shoot. Backward.
Yeah.
We're finding pH. I'm doing the other guide. Oopsie. Yeah, we're doing it right, and I'm like, hold on. Yeah.
All my losses already lost.
Yeah. Sorry. Misha is getting you guys lost. Okay. pH equation is pH is equal to negative logs of H plus, right? Whoopsie. See, I like to always write them the other way around sometimes. So be careful with that. Yes, definitely. That's why I was looking at my pH and I'm like, hold on, can't be right. All right. So we're going to do that. So we're going to say negative logs of 0.5. So we're going to get 0.03. Wait, no, 0.3. 0.3. 0.30. Yeah. Okay. Right. 0.30. Yeah, 0.30. Oh, funny enough, they kind of come to the similar number. Anyway, the other one is 0.0075, so we're gonna get about 2.12, right? And then and then this one will give you 5.47. And then this one will give you 7.82. Okay.
What about polyprotic acid?
Oh, we'll talk about that one. We gotta to assume only the first H matter. Okay. So the solution in the last row of the table above is very diluted, as you can see here, right? That's very low concentration, right? Diluted. Okay. Is this value of pH in a solution? Okay. I accidentally deleted. Supposed to say reasonable. Is this value of pH reasonable? If not, explain what the pH of this dilute solution should be and why. So you're trying to calculate this, and then you got this number, and you're gonna say, is this a reasonable number? Well, let's talk about it. What is the pH of 7.82 mean? pH greater than 7 is basic.
No, it's 31.
Okay. Basically, do you think it's reasonable? No, it's not. You can't dilute it until it's got basic.